So far in the other videos, we've talked about translations and reflections, and rotations is the next one. So rotations is the third transformation, and a rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. And a rotation is also an isometry, which means that it is a congruent transformation. So all the pieces, once they are the pre-image or the image, that they are congruent to each other. So the angle of rotation is when we have rays drawn from the center of rotation to the point and its image. So the pre-image in our figure on the side for these little flags is the blue RQ, so segment RQ, and then the image, so after it's been moved, is R prime Q prime. Rotations can be clockwise, which is towards the same way that the clock moves around, or counterclockwise, which would be the opposite direction. And this unit, if it does not say, the default is going to be counterclockwise. This is one section that you want to make sure you mark correctly. So this is a picture about rotations, about the origin, and that's how we're going to be rotating all of our figures. And we can rotate them more than 180 degrees. So most of the time that we're going to see it is going to be one of these three down here, and here are the special little rules for how to do this. So this is one you do need to know the rules, so you need to memorize these. Remember that these are only for counterclockwise, so if it says clockwise, we'd have to do something different. So first we need to, for this problem, we need to write down the original coordinates. So I is over at 4, 2, A is at 4, negative 2, and K is at 2, negative 3. So next, if you notice in my picture, is I wrote down what the rule was from that previous slide. So for 90 degrees counterclockwise, we need to rotate it this direction. And most of it's, if it's 90 degrees, if you think about it, each of these quadrants is 90 degrees. So in a sense, all these points are going to be moving one quadrant over. So I will be over in second quadrant. A and K will be in quadrant 1 because they're going to rotate one quadrant to the left. So we need to take each of the y values and make them negative, and now they're going to be the x value, and then our x's are going to be moved to the y. So that would mean that I prime, since my x has to be now the y value, and then my y is now going to be my x, but I need to make it the opposite sign, so it should be at negative 2, 4. For the a prime, I need to do the same thing. So my y value is a negative 2, but then I need to make it the opposite, so it'll be a positive 2. The x is now my y. For k prime, I am going to have a negative 3 for the y, or for the x from the y, but I need to make sure it is opposite, so it's negative y, and then my x is now my y. So when I graph these coordinates, this is what I get. One thing I do want you to write down is turn your paper 90 degrees clockwise, and this is because we did counterclockwise, so you need to turn your paper the opposite direction. And if I turn it 90 degrees clockwise and then use my new x and y axis as the pre-image points, so then graph these points right here on that graph, and the new x and y axis, so after I've moved my paper, then I'm using them just like it would normally. So my 4, 2, and then my 4, negative 2, and then 2, negative 3, that I would graph those coordinates, but then I turn my paper back and it'll be back to what these final coordinates are over here on the right. So I'll show you this in class, but I'm just going to mention it this one time so you can write that on your paper. In this problem, we're going to rotate it 180 degrees, and remember, since it does not say, we are going counterclockwise. So on our graph, we can think of this would be 90 degrees. So 180, our picture should end up down here someplace. So all of these coordinates, since they all started in quadrant 2, should all end up down in quadrant 3. So for our rule, we've got negative x, negative y, and that's because it's 180 degrees counterclockwise. The original coordinates that we've got for g is negative 3, 3, for n is negative 2, 4, and for r is 0, 2. So when we switch them around, we're going to be putting their x's, if you notice, are in the same location, but they're opposite signs. So we're going to have a positive 2. Here we'll have a 0 still. Here we'll have a positive 3. But then my y's are going to be the opposite sign as well. So I need to have a negative 4, negative 2, and then negative 3. So if we go ahead and graph those coordinates, this is what we will have. Make sure that you graph and you label your new coordinates as your r prime, n prime, and g prime, so we can tell the difference when you're looking at the picture as well as your coordinates over here. So this should be n prime, r prime, and g prime. All right, for the next picture, you can see that the blue figure is the pre-image, the red figure is my image, and if you see that it is rotated, remember all of our rotations are going to be isometries, which remembers that all of our pieces, once we move them, are still congruent to each other. So this 5 is going to be congruent to my x, and I know then that these two pieces will also be congruent to each other. So my x plus 7 will be equal to my 3y. Well, this purple equation, I can't solve anything, but I can use this by plugging it in. So I'd have 5 plus 7 equals my 3y. So 12 equals 3y. And if I divide that by 3, my y would equal a 4. So y is equal to 4, and my x is equal to 5. On this page, we are just going through some basic questions you're going to see in your assignment, so identifying the type of transformation we've covered so far, either a translation or a slide, reflected or you're flipping it, or the rotation is you're turning it around in a circle. So we need to explain the reasons why. So in this first one, if you notice right here, it is literally a reflection, and it is because of the reflection on the water. Next one would be a rotation, because you'd turn the steering wheel. So think if it would go around in a circle like that. Lastly, for this last train would be a translation, because your train is going to be sliding, and it will either go left or right. All right, so just like we ended the last video, we're going to go through and we're going to translate something, and then we're going to rotate it. So we're going to do 2 of the pieces we've done so far. So remember, this x plus 4 right here means that it's moving to the right 4 spaces. The minus 5 tells us it's moving down 5, so I need to add 4 and subtract 5 accordingly. So I would get a 6 and then negative 4. So that's after the translation. Then if I need to rotate it 90 degrees, my rule for that is negative y comma x, if you look back to our rules. So that means that I need to take my x value, which is my 6, and now that's my y. My y, that's negative 4, I need to move it up in front, and I need to make it so it's the opposite sign. So it become a plus 4 and a positive 6. This would be my p prime, where I would end up. So my answer would be positive 4, positive 6, and that would be my letter C. So if you can see where we start, we would have my coordinate at 2, 1, so right there in the purple. And then once I translate it to this new coordinate, so I would move it to the right 4 and up 5, or down 5, sorry, that I would end up down here at negative 4. Then I need to rotate it 90 degrees, and notice it's going to be clockwise. So just something I just realized, that let's change this so it says counterclockwise. So we can use our rule. If it's not counterclockwise, then we cannot use our rule. So let's change it to counterclockwise so we can stick with our answer. So then once we go counterclockwise, we need to rotate it this direction. We would end up at 4 and then positive 6 way up here. And that's where our final ending coordinate was. Right there, I'll make it in red. So that's where my final coordinate was after I rotated it counterclockwise 90 degrees.